Hi everyone, Tina here, and today I'd like to talk about probability tree diagrams. You'll need to know about this idea for both the Foundation and Higher GCSE maths courses. Probability tree diagrams are really useful when you have a combination of events happening. In this video, I'll run through a few examples to show you how they work. Example 1. Rachel has 2 bags. In the first bag, there are 4 red balls and 6 green balls. In the second bag, there are 3 red balls and 5 green balls. Rachel takes at random a ball from the first bag. She then takes at random a ball from the second bag. Part A, complete the probability tree diagram. So first thing we could note down is that in the first bag, there are a total of 10 balls. In the second bag, there's a total of 8 balls. This will be useful when we're trying to work out the probabilities. So in the first bag, the probability of selecting a red ball is going to be 4 out of 10. And the probability of selecting a green ball will be 6 out of 10 because there are 4 red balls and 6 green balls, 10 in total. Something really important to notice here is that on probability tree diagrams, probabilities on any set of branches always add up to 1. And this is because in any scenario, all probabilities always add up to 1. If we move on to the second bag now, the probability of selecting a red ball from the second bag would be 3 out of 8. And for a green ball, it would be 5 out of 8. Again, those two add up to 1 whole. We're still talking about the second bag here, so 3 out of 8 for a red ball and 5 out of 8 for a green ball. And that's part A done. That is the complete probability tree diagram. Part B, they want us to work out the probability that Rachel takes 2 green balls. So I find the best way to do this is to highlight or mark the pathway that you're interested in on the probability tree diagram. So in this case, we want a green from the first bag and a green from the second bag. And then when you do this, when you look across a tree diagram like this, you multiply the probabilities together. So the probability of getting 2 green balls is going to be 6 out of 10 times 5 out of 8. And that gives you 30 out of 80 for your final answer. Example 2. Each day, Paul wears either a black tie or a red tie to work. On any day, the probability he wears a black tie is 5 out of 9. Part A, complete the probability tree diagram for Monday and Tuesday. So this time they're giving us the probability that he wears a black tie. So we can actually just put that straight on to the tree diagram for black tie. It does say on any day, so that means the probabilities won't be different on a Monday versus a Tuesday. So we can put 5 over 9 on these branches for black tie as well. Then the probability he's going to wear a red tie will be 4 out of 9 because that's how those two probabilities would add up to 1 whole. We then copy that across for the red tie and we're done. Part B, work out the probability that Paul wears different coloured ties on Monday and Tuesday. So this time the pathways that we're interested in are these. So black tie on Monday and then red tie on Tuesday. Or he could wear a red tie on Monday and then a black tie on Tuesday. Those would be the pathways for different coloured ties. We're going across the tree diagram to start with, means we want to times the probabilities. So for this one, it will be 5 over 9 times 4 over 9, which is 20 over 81. And for this one, it will be 4 over 9 times 5 over 9, which again is 20 over 81. Now to get the final answer for the probability, we want to go down the tree diagram using these two probabilities. And when we go down, we add the probabilities together. So 20 over 81 plus 20 over 81 gives 40 over 81 for the final answer. Last example, Bradley gets the bus on Saturday and Sunday. The probability that Bradley's bus will be late on any day is 0.2. Part A, complete the probability tree diagram. So this time they're giving us the probability as a decimal, and that's fine. So we can say the bus is going to be late on Saturday with probability 0.2. Therefore, it will not be late with probability 0.8. Again, those two need to add up to 1. It says on any day, so we'll copy those probabilities across for Sunday, and that's it for part A. Part B, work out the probability that Bradley's bus is late on at least one of these days. So this time there are quite a few different pathways that would lead us to this. If it's late on at least one of these days, it could be late on both days, it could be late on just Saturday, and it could be late on just Sunday. So I've highlighted the different pathways. Now I'm going to go across and multiply the probabilities together. So for this pathway, we've got 0.2 times 0.2, 0.04. This one, 0.2 times 0.8, 0.16. And this one, 0.8 times 0.2, 0.16 again. Now we want to go down the tree diagram. So we're going to add all of these 3 probabilities together. And when we do that, we get 0.36 for the final answer. Now that was quite a lot of work, so I'm going to show you the exact same question, but this time using a shortcut method, which you might want to try. The shortcut is, if you're looking for the probability that Bradley's bus is late on at least one of these days, what you can do is take one whole and then subtract the probability that Bradley's bus is late on neither of the days, because this is the only pathway that is not included in the probability that we want. And remember, all probabilities in any given scenario always add up to 1. So if we do 1 take away that pathway, we'll get the others. So let's copy across the probabilities from before, 0.2 and 0.8. Now let's times across the tree diagram, but only for that one pink pathway, 0.8 times 0.8, which is 0.64. And then we can do one whole, take away 0.64, which gives us 0.36 again. So same answer, different method. A good way to notice if you can do the shortcut method or not is to look out for the words at least one. That's usually a clue that you can do the shortcut method. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks and see you next time.